Hello everyone, welcome to the Learnable channel. Today we'll be talking about moons. Um,
And Unit 3 for Astronomy 101.
this is our third video in the Unit 3, so let's get started.
All right, so let's start the video with some information and facts. For the size and distance
Our
of the
moon.
moon, yeah, of our moon, not bad. Uh, the moon has a radius of about 1,000 miles or 1,070 kilometers, and the moon is an average of 240,000 miles away from the Earth, or 380,000 kilometers. For the orbit and rotation, the moon is rotating at the same rate it revolves around the Earth, which is called synchronous rotation. So the same hemisphere faces the Earth all the time. For the structure of the moon, its core is proportionally smaller than some other terrestrial bodies' cores. The solid iron-rich inner core is 149 miles in radius, or 240 kilometers. It is surrounded by a liquid iron shell, which is 56 miles thick, or 90 kilometers thick, and it has a partially molten layer with a thickness of 93 miles, which surrounds the iron core, or 150 kilometers. Now, for the surface, nearly the entire surface is covered by a rubble pile of charcoal gray, powdery dust, and rocky debris called lunar regolith. Beneath it is a region of fractured bedrock referred to as the megaregolith. The dark spots of the moon are solidified lava beds from earlier periods of lunar evolution, when the moon was still volcanically active. The heat source for these eruptions came from the tidal heating, which is one caused by the slight warping of the moon as it rotates around the Earth's gravity well. Over millions of years, this heat can build up underground until it is sufficient to trigger a volcanic eruption. Now over to Mona to talk about moon formation.
So the first theory in how the moon formed is the giant impact hypothesis, and this is the most likely one, sometimes called the big splash or the Theia impact. This suggests that the moon formed from the ejecta of a collision from an early Earth and a nearly Mars-sized planet. Approximately 4.5 million years ago in the Hadean eon, about 20 to 100 million years after the solar system coalesced. The colliding body was called Theia. The analysis of lunar rocks published in a 2016 report suggests that the impact might have been a direct hit, causing fragmentation and thorough mixing of both parent bodies. The giant impact hypothesis is currently the favored scientific hypothesis for the moon formation of the moon. Supporting evidence includes um, the Earth's spin and the moon's orbit have similar orientations. The Earth system contains an anonymously high angular momentum, meaning that the momentum contained in the Earth's rotation, the moon's rotation, and the moon revolving around the Earth is significantly higher than other terrestrial planets. A giant impact might have supplied this excess momentum. Other evidence include that the moon samples indicate that the moon was once molten down to substantial but unknown depth. This might have required more energy than predicted to be available from the accretion of a body of the moon size. An extremely energetic process, such as a giant impact, could provide this energy. The moon has a relatively small iron core, which gives the moon a lower density than Earth. Computer models of a giant impact of a Mars-sized body with Earth indicate that the impactor's cores would likely penetrate Earth and fuse with its own core. This would leave the moon, which was formed from the ejecta, that was not fused with proto-Earth, with less remaining metallic iron than other planetary bodies. The moon is depleted in volatile elements compared to Earth, vaporizing at comparably lower temperatures. They could be lost in a high energy event, with the moon's smaller gravity unable to recapture them while Earth did. There is evidence in other star systems of similar collisions resulting in debris disks. Giant collisions are consistent with the leading theory of the solar system formation. The stable isotope ratios of lunar and terrestrial rocks are identical, implying a common origin. Now, other hypotheses include the capture theory, which suggests that the moon was a wandering body, like an asteroid or a planetesimal in the solar system, and was captured by Earth's gravity as it passes nearby. Another hypothesis is the accretion hypothesis, which proposes that the moon was created along with Earth at its formation. And the fission theory suggests that Earth had been spinning so fast that some of the material broke away and began to orbit the planet. Now, Banu will be talking about the moon cycle.
All right, so the start of the moon cycle is a new moon, which is an invisible phase of the moon with the illuminated side of the moon facing the sun and the night side facing Earth. This occurs when the moon's ecliptic longitude is at an angle to the sun of 0 degrees, as viewed from the center of Earth. This phase occurs because the moon is between the sun and the Earth, so we are unable to see the illuminated side of the moon. Next is the waxing crescent. The silver sliver of a moon occurs when the illuminated half of the moon faces mostly away from Earth, with only a tiny portion visible to us from our plane. This phase occurs because as the moon continues its orbit around the Earth, more and more of its illuminated side becomes visible to us. Now, onto the first quarter. The moon is now a quarter of a way through this monthly journey, and we see half of its illuminated side. People may casually call this the half moon, but remember, that's really not what you're looking at. You're just seeing a slice of the entire moon, half of the illuminated moon. This occurs when the moon's ecliptic longitude is at an angle to the sun of 90 degrees, as viewed from the center of the Earth, and occurs because as the moon continues its orbit around the Earth, more and more of its illuminated side becomes visible to us. Now on to waxing gibbous. Now most of the moon's day side has come into view, and the moon appears brighter in the sky. This phase occurs because as the moon continues its orbit around Earth, more and more of its illuminated side becomes visible to us, like I said already. Now the full moon. This is as close as we come to seeing the sun's illumination of the entire day side of the moon. The moon is opposite of the sun as viewed from Earth, revealing the moon's day side. This occurs when the moon's ecliptic longitude is at an angle to the sun of 180 degrees, as viewed from the center of the Earth. This phase occurs because the moon continues its orbit around the Earth and eventually reaches a point where it is directly opposite from the Earth in relation to the sun, allowing us to see its fully illuminated side. Now, waning gibbous. This phase after the full moon, where most of its day side is still visible. This phase occurs because as the moon continues to orbit around the Earth, less and less of its illuminated side become visible to us. Third quarter. The phase after waning gibbous, where you see half of its illuminated side again, like the first quarter. It occurs when the moon's ecliptic longitude is at an angle to the sun of 270 degrees, which is viewed from the center of the Earth. This phase also occurs because as the moon continues its orbit around the Earth, less and less of the illuminated side becomes visible to us until only half of it is visible again. And the final phase before new moon, called waning crescent, is where only a tiny portion visible to us is visible to us when it's planet. This phase occurs because as the moon continues to orbit around Earth, less and less of its illuminated side become visible to us, as always, and only a tiny portion remains visible before it reaches moon again. And the length of time it takes for each phase to occur varies slightly, but on average it takes about 29 to 30 days. The four primary phases occur usually about a week apart. Now on to Monday to talk about the lunar eclipse.
A lunar eclipse is an astronomical event that occurs when the moon moves into the Earth's shadow, causing the moon to be darkened. Such alignment occurs when during an eclipse season, approximately every 6 months during a full moon phase, when the moon's orbital plane is closest to that of the Earth's orbital plane. During a lunar eclipse, two shadows are cast on the moon by the Earth, the umbra and the penumbra. The umbra is the inner darker shadow that gets smaller and smaller as it goes away from the sun. It is the dark center of the eclipse shadow. The penumbra, on the other hand, is the outer lighter shadow that gets larger as it goes away from the sun. During the total lunar eclipse, the entire moon enters the umbra and appears to turn red in copper due to the bending of sunlight around the Earth's higher atmosphere. A partial lunar eclipse only occurs when only part of the moon's surface is covered by the umbra, while a penumbral lunar eclipse occurs when the moon only enters the penumbra. Now let's talk about the blood/red moon. A blood moon is a phenomenon that occurs during a total lunar eclipse. During a total lunar eclipse, the Earth moves between the sun and the moon, casting a large shadow on the moon and putting it in darkness. Despite the fact that the Earth is casting a shadow on the moon, we can still see it because some of the sun's light is bent around the Earth by our atmosphere and is directed towards the moon's surface. As the sunlight through the Earth's atmosphere gets filtered and scattered, with shorter wavelengths, primarily orange and red in color, being refracted and directed towards the moon. This causes the moon to appear reddish or copper in color, hence the name blood moon. Now, Banu will be talking about supermoons.
And supermoons occur because the moon's orbit around the Earth is not a perfect circle, but rather elliptical, or like I forgot the name. Anyway, let's move on. This causes the distance between the moon and the Earth to vary, with the closest point in the ellipse being called the perigee and the furthest point being called the apogee. When the full moon appears at the perigee, which is the closest point to Earth, it is slightly brighter and larger than a regular moon, and that's when we get a supermoon. And now a blue moon is a term used to describe a rare event when there is an additional full moon in the season or calendar. There are two different definitions for the blue moon. A seasonal blue moon is the traditional definition and refers to a third full moon in a season that has 4 full moons, according to Maxwell. And a monthly blue moon is more recent and widely used and refers to a second full moon within a single calendar month. It's also important to note that neither of these definitions have anything to do with the color of the moon. The moon does not turn blue like it shows in the picture. But rather due to the rarity of the event, it's named blue moon. Now on to Mona to talk about exomoons.
Yeah. Before we do that, however, on very rare occasions, the moon can appear blue in color due to atmospheric conditions, such as the presence of smoke or dust particles in the air. So that's why we can see the blue moon. So now let's talk about exomoons. Exomoons are moons of an exoplanet. We have not discovered any exomoons yet because their presence is very hard to detect since they're so tiny. However, there is one possible candidate, which is Kepler 162.5b, which is a Neptune-sized moon and is gaseous, which orbits the Kepler 1625b planet, which is a Jupiter-sized world. It is also possible that the Kepler 1625b one might have its own moon, but no evidence has been found yet. Gas moons is a hypothetical moon that is made up of gas, while submoons are moons of a moon, and we have not discovered any submoons yet. And the candidates which we were talking about earlier, Kepler 12625b might be a gas moon, and that moon also might have a submoon, which we don't know yet. So now let's talk about some interesting moons. So we'll be talking about Europa, Euclideus, Ganymede, Callisto, Io, and Triton. All these moons are very interesting, and they have very interesting properties and stuff. So let's get started. And all of these are in our solar system, by the way. So first, let's talk about Europa. Europa is a moon of Jupiter and was discovered by Galileo Galilei, who first observed them in a homemade telescope in January 1610. It has a radius of 969.84 miles, and the red streaks on Europa are due to contaminating minerals rising from beneath the icy crust, possibly salts from the underground ocean. The regions of modeled red are chaotic terrain, parts of the moon surface which have been disturbed by icy material that has been broken and shifted around. Scientists are sure that under the ice crust of Europa, there is a saltwater ocean with more than 2 times the amount of water on Earth. Europa is primarily made up of silicate rock, and has a water ice crust and probably an iron nickel core. It has a very thin atmosphere composed primarily of oxygen, cracks and streaks serrated surface. NASA is sending its Europa Clipper spacecraft to Europa to investigate whether Europa has the capability to support life, and its launch date is October 10th, 2024. NASA also might send the Europa lander between 2025 and 2030, where it will land on Europa. Then it will drill through Europa's ice to go to the subterranean ocean. Europa is the solar system's smoothest object, suggesting that its surface is remade by interior processes rather than more frequently than most worlds other than Earth. Europa vents plumes of water 160 kilometers above the surface, so there is a potential for life to exist from the chemical energy from hydrothermal events, just like Earth. Now, Bono will be talking about the next moon, Euclideus.
And Euclideus is one of the moons of Saturn, about as wide as Iron Sun, which is 310 miles. It orbits at a distance of 148,000 miles or 238,000 kilometers. And in 2005, NASA's Cassini spacecraft discovered that icy water particles and gas gush from the moon's surface at approximately 800 miles per hour, 400 meters per second. That is very fast. Eruptions appear to be continuous, generating an enormous halo of fine ice dust around the Enceladus, which supplies material to Saturn's E ring. Only a small fraction of the material ends up in the ring, however, most of it falling like snow back to the moon's surface, which helps keep Euclideus bright white. The water jets come from relatively warm fractures in the crust and the ocean underneath the ice, which scientists informally call the tiger stripes. Several gases, including water vapor, carbon dioxide, methane, perhaps a little ammonia, and either carbon monoxide or nitrogen gas, make up the gaseous envelope of the moon, along with salts and silica. Scientists also think that the moon's ice shell may be as thin as half a mile to 3 miles at the South Pole. The average global thickness of the ice is thought to be about 12 to 16 miles. British astronomer William Herschel spotted Euclideus orbiting Saturn on the 28th of August, 1789. Euclideus could be great for supporting life, as the hydrothermal activity from the mantle could give chemical energy for life to survive in the global ocean. Also has the essential chemicals and amino acids in the ice to support life discovered by the Cassini spacecraft. Now to wanting to talk about the next planet.
Yeah. So next we'll be talking about Ganymede. Ganymede is the largest moon of Jupiter and the largest moon in our solar system. It has a very thin atmosphere that includes oxygen, O2, and possibly ozone, O3. It was discovered by Galileo Galilei on January 7th, 1610. It was explored by the Galileo space probe. It has a radius of 1,636.8 miles. It is also the only moon with a magnetic field. It has 6 layers, so with a rocky crust, then hexagonal ice, then a saltwater ocean, then tetragonal ice, then a rocky mantle, and then a liquor iron and iron sulfide core, and then a solid iron core. There could be life in the saltwater ocean of Ganymede. Now, Bono will be talking about Io.
Io is a moon of Jupiter. Io and is the most volcanically active world in the solar system, with hundreds of volcanoes, some erupting lava fountains dozens of miles high. It has a thin atmosphere composed primarily of sulfur dioxide and was discovered by Galileo Galilei on January 8th, 1610. It was also explored by the Galileo space probe. It has a radius of just around 1,100 miles and is the closest moon to Jupiter. It has 4 layers: a crust, and a stenosphere, a mantle, and an iron sulfide core. Now I'm wanting to talk about Titan.
So, Titan is the largest moon of Saturn and the second largest moon in our solar system. It is the only moon known to have a dense atmosphere and is the only known object in space other than Earth on which clear evidence of stable bodies of surface liquid have been found. Lakes of ethane, ethane, and methane on Titan, Saturn's largest moon, have been detected by the Cassini space probe. There could be life on the river and lakes of Titan. Titan's crust is made out of water ice and has rich hydrocarbon sediment. It then has a subsurface ocean, and then a high pressure ice shell, and then finally a core made out of rock and ice. The radius is 1,599.9 miles. Christian Huygens discovered Titan in 1665. Now, Banu will be talking about Callisto.
Alright, so Callisto is Jupiter's second largest moon and the third largest moon in the solar system. Has a thin atmosphere composed mostly of carbon dioxide and discovered by Galileo Galilei on January 7, 1610. The reason why Callisto's surface is colorful is because the brighter areas are mainly just ice, and the darker areas are highly eroded ice-core material, which we don't know what it's made of yet. And this was also explored by the Galileo space probe. It has an ice crust and a saltwater global ocean, where life could exist, and then a rocky ice mantle and core. And its diameter is just under 3,000 miles. On to Mona for Triton.
Right, now this is the furthest moon we will be talking in the solar system. Triton is a moon of Neptune and was most likely captured from the icy Kuiper belt. The wrenching change in the moon's trajectory probably heated it up, perhaps enough to warm a global ocean below the crust. Triton has 5 layers. The first one is a frozen nitrogen crust, then a subsurface ocean, then an icy mantle, and then a core made out of rock and metal. During the flyby of Voyager 2, it found dark plumes consisting of water as well as possible lava-like flows on the surface, indicating an ocean underneath the geologically active icy crust. The diameter is 1,680 miles. Triton was discovered by William Lassell in 1846. It could have life supported from the chemical energy from the hydrothermal vents. So, thank you everyone for watching our video. We hope you liked it. And so, and please make sure to subscribe, like and share this video. You guys will be the pillars of growing this channel, and we really appreciate that. So thank you again for watching. Our next video will be our last video in this course, and it'll be talking about the history of space exploration by humans in our solar system.
Yeah, we'll also have a conclusion video, and that's it for today. Bye.
Bye.